Hi students, welcome to Science Extension and Module 3, the Data, Evidence and Decisions. This is video 15 and we're going to look at the F-test. For this particular video, we're going to encourage you to be able to apply appropriate statistical tests of confidence to datasets, including but not limited to the F-test. So what is the F-test? Well, the F-test is used to compare the variance or the spread of data in two different groups. It tells us whether two samples are likely to have come from populations with the same variance. And given we've made some assumptions about comparison of two means that are coming from two normally distributed populations, there is some importance in trying to determine whether or not two sets of data are actually similar in their variance. The F statistic is calculated as the ratio of the variance between the two samples, and it's often very important in more complex tests like ANOVAs or analysis of variance. The F statistic is the variance ratio, and it measures the degree of diversity between two or more samples. It allows the calculation of within and between group datasets. So, for instance, it could be used to determine if the variation in science test scores between two different schools is notably different. As always, it's not critical for you to be able to work the mathematics of each of these test statistics, but it's probably useful to understand exactly what's going on. So you might remember some of the discussions we've had around standard deviation, and you probably already understand something about how to calculate the standard deviation. And really what we're looking here is looking at the variance, not the standard deviation, but looking at a comparison between two different samples. The F distribution is the probability distribution resulting from the comparison of the variance of these two samples using the F calculation. And if the variance between the two samples are equal, obviously if variance 1 equals variance 2, then clearly we're going to have an F statistic of 1. So what does this look like? If you're working in the Google environment, Google Sheets, you just have to put the F-test and then the two ranges of results. So I said we can compare, say, two different sets of results from two different schools perhaps, and then we can see whether or not they've come from similar variance. So when we're calculating our test statistic, we need two ranges. That is a range of scores for one group and a range of scores for the second group. So you can see I have some data here, Group A and Group B. These could represent the scores on a particular test, and they should be from two classes or possibly from two groups in two different schools. And what we want to try and do is determine what the degree of variance is between each of these two samples. And we can do that using our F-test. If you're going to use Excel, then of course we always need that equal sign at the front, which Excel recognizes as a formula. The F-test is one of the statistical tests that you can do. And again, it'll walk you through this process in Excel. So you just select your two sets of data and it will spit out a value. You can see as you are adding these values in, it's automatically starting to get this. And it shows me the formula result here of my F-test. My value for the formula result is 0.62. Now this is actually a p-value. So one of the things that I am looking at when I look at this particular set or these two sets of data is there does look like some slightly higher values in Group A than in Group B. But what I'm always interested in is whether those differences are statistically significant. So the problem that I have here is with a p-value of 0.62, I am well above the 0.05 mark. And I need to be below that mark in order for me to reject my null hypothesis. Therefore, I have to accept my null hypothesis that there's no real difference in the variance between Group A and Group B. To pull this out in a little more detail and perhaps to look at the sort of data that you might get from the data analysis tool, and I won't go through this on Excel again because it's the same drop down from the data analysis tools. This time we're looking for the F-test, two samples for variances, and you can see just like I did with my basic calculation, I have here my two sets of data. So they have come from here, the two different columns of data, and I have set my alpha value, so which is our standard value of 0.05. And what you can see that it will spit out to me is this sequence of data, and you can see what it's given me is a one-tail statistic. So it's giving me basically just looking at one direction. If I used a calculation in Excel just by calculating the F-test statistic, it does it on a two-tail. So you're going to get double the value as we consider both lower and higher variances for this particular test statistic. I've also, just to continue to give you an idea of the value of each of these things, you can see descriptive statistics are one of the things in our data analysis drop-down menu. And just by clicking on that, I've been able to get this good selection of stuff, and you can see the sample variances are here and here. Now, numerically, they are different, and there is a bit of a kurtosis, there's a bit of a skew that's happening, but it's not too significant, and as I've just calculated, it is statistically not significant at all. So I would actually accept my null hypothesis in this case that there's no difference in the variance between Group A and Group B in terms of their marks. Like we talked about with the t-test and the chi-squared test, there are some assumptions that are associated with the use of the F-test. And the first and the most important one is that the populations are normally distributed. So we're trying to pull from a normal distribution. In terms of variance, the larger variance is usually the one that's used as the numerator and the smaller one as the denominator. So my test statistic is often going to come out as a number greater than 1. Now, if you have a look at this video, you'll notice that the value I had came out as less than 1, and that's because the group that I used first, Group A, actually had a lower variance. Now, it's not critical, but it's one of those things that just helps in the interpretation of the statistics if you are consistent in the way that you do your calculations. Like for most of the other things that we've talked about, there needs to be some homogeneity in terms of the variance between the two different groups. And there also needs to be some independence. That is, the populations or the samples that you're comparing when you're carrying out your F-test need to be independent of one another. So I would not use the F-test, for example, if those two sets of statistics were basically from the same class that were doing a pre and post test, or doing two tests at two different times of the day, or something like that, where people that were in one group were also in the other group. So I need to remember that with my F-test, I'm looking to compare variance. There's kind of going to be an assumption that if the same people are in the two groups, then the variance is going to be the same. So it's going to be a wasted exercise. So I do need to make sure that my samples are independent of one another. The F-test is the third in our little series of tests: F-testing, t-testing, and chi-squared testing. They're three that you need to consider when you are carrying out statistical testing on your own data for your student research project. But there are a couple of other things that you can do as well, and we'll have a look at those in subsequent videos. Thanks for watching.